to 1.5. I welcome all the students for the laboratory microcontroller laboratory session 2. In this video, we will see about how the add operations can be executed in ARM microcontroller. Prepared by Dr. Vinod Kumar, Associate Professor, Department of CSE and Data Science, ATMI College of Engineering, Mysore. So continuing with the first program, where we were using a Keel software to observe the various registers in previous session. In today's session, we will see about how to add two numbers as indicated previously. So here you can see the area here you can see the area program code read only. As indicated earlier, the area means you are allocating a area in the ARM microcontroller. Program is the word of a file name. It is a case sensitive. The code, you are writing a code on it, and it's a read only operations. So here generally you can observe how the instructions will be written. It will be written in the fashion opcode, destination, source. Opcode, destination, source. Here the source can be a data or an address. So coming to the first instruction, move 05 to the R5 registers. Similarly, move 07 to R7 registers. In this opcode, you can observe add R2, R5. R5 and R7 will be added and it will be stored in R2 registers. So this is the instruction which will highlight such a way that whatever the data that is stored in R5 and R7 will be stored in R2. So stop means the operation where it will be keep on executing in the same instruction. Thank you. Now moving on, here you can see the code has been written on the Keel microvision. So it has been added to the source group with no errors. So upon running, you can see the register R2 and R5 and R7. What are the modifications or changes you can observe? So always you go for step in operation so that the each instructions you can able to analyze the registers, how it is being moving. So now let us go to the microcontroller, Keel microvision, how to run the program. So here the procedure remains same. So you need to create a project. So since it is a continuation video of lab session 1, so we already created a project. Here I created a new file named as program2.asm and it has been added to the source group. So the same instruction. Always make sure that for all the instructions, apart from stop, you have to give one tab of space for all the expression. Otherwise, you will get error. So you can observe here, I'm deleting the tab. So if I want to rebuild again, it will show an error, unknown opcode, because so the area instruction will take after one tab. So now I have modified, now I provided one tab to the area program code read only. Now let us see the error. So here we can observe 0 errors, 0 warnings. Now I will be starting and stopping the debug session. So evaluation mode has been activated and it is having a code size limit of 32 kilobytes. So here you can see all the registers. This is current program status register and this is saved program status register. So these are the two registers wherein you can observe what is the actual happening in each bit. So here you can see all the registers are default will be stored with 0 value. So let me execute one by one. So you can go for F11 or you can click on step on one line. So default it will be starting with the after the area code. So let me execute the step in. You can see the 5 has been moved to R5. Similarly, the 7 has been moved to R7. Now the add operation has been performed here and it is stored to R2. That is 5 plus 7, it is 12. So the 12 equivalent in hexadecimal is 0, C. So even if I go to step input, so this instruction will be keep on executing as long as the program is been activated. So now let me stop the debug session. Here, let me change the value to hexadecimal. Let me give A. Let me give A and 10. Let me save. Let me rebuild the file. Start and stop the session. So here you can observe all the registers will be set to default values. Let me start the execution by pressing on the step in. You can see R5, A has been allocated the data. For R7, 10 has been allocated. So once if it is had, you can see it is 1A. So 1A will be stored in R2 and the instruction will be keep on executing unless we stop the execution. Let me stop the debug session. So in this video, we are able to run the operations based on addition. Similarly, we can do for any subtraction, multiplication and division. So here, basically, we have done for decimal and hexadecimal. Thank you.